everyone. We are discussing about the subject Internet of Things. In this we are going to learn about IoT World Forum Standardized Architecture. Myself Divya, working as Assistant Professor in the Department of Computer Science and Engineering, SRKR Engineering College, Bhimavaram. The objectives of the class are to learn IoT World Forum Standardized Architecture and to explore deeply into all the 7 layers of the architecture and to gain some knowledge on edge computing. Coming to the IoT World Forum Standardized Architecture, it was a 7-layer reference model which was developed in 2014 by a committee led by Cisco, IBM, Rockwell Automation and others. As you have learned ISO Standardized Architecture, Open Systems Interconnection OSI model in the computer networks, this was not same like that. It was different and it was developed only for the Internet of Things. Here this model offers a clean, simplified perspective on IoT. Here this architecture includes edge computing, data storage and access. Coming to the World Forum Standardized Architecture, here we are having 7 layers. Let us have a discussion from bottom to top. So here layer 1 deals with the physical devices and controllers, which are the things in Internet of Everything. IoE is Internet of Everything. Means nowadays every device is being connected to the internet network. Here this layer includes sensors, devices, machines, intelligent edge nodes that gathers data from the environment or the surroundings. Coming to layer 2, that is dealing with the connectivity, which involves communication and processing units, and this layer is responsible for reliable communication and transmission of data between devices and the network. Coming to layer 3, that is edge computing. It involves data element analysis and transformation of data before sending data to the centers. Coming to layer 4, that is data accumulation, which deals with the storage of data and it deals with how to store data coming from the bottommost layers. Coming to layer 5, that is data abstraction, and this layer maintains consistency and consolidates data at one place by using aggregation and data access. Coming to layer 6, it contains applications that operate on data for reporting, analytics and control. Coming to layer 7, that is collaboration and processes that involves more people and business processes for better utilization of IoT features in business and industry. So these are the 7 layers which are there in the IoT World Forum Standardized Architecture. So coming to the introduction of this architecture, this model is defining a set of levels with control flowing from the center. This could be either a cloud service or a dedicated data center to the edge, which includes sensors, devices, machines and other types of intelligent end nodes which we have discussed in layer 1. In general, here the data is traveling up the stack, originating from the edges and goes to the northbound to the center. Here this model is enabled to achieve the following. Those are the decomposition of IoT problem into smaller parts, identifying different technologies at each layer and how they relate to one another, defining a system in which different parts can be provided by different vendors, and to have a process of defining interfaces that leads to interoperability, and to define a tiered security model that is enforced at the transition between the levels. So let us go into deep insight of all the 7 layers. Coming to layer 1, that is the physical devices and the controllers layer. Here this contains all the things which are there in Internet of Everything, IoE. It includes various endpoint devices and sensors that send and receive the information. Here the size of the things, if you observe, they can be miniature things to the giant machines in a factory. Here the core function of this layer is to generate data and is being capable of being queried and controlled over a network. Coming to layer 2, that is connectivity layer, and it deals with the first and foremost thing, that is communications, and it is responsible for reliable and timely transmission of data. Here it includes transmissions between layer 1 devices and the network, and between the network and information processing that occurs at layer 3. It is acting as an interface between layer 1, layer 2 and layer 3 and layer 2. So here the connectivity layer includes all the networking elements of IoT and does not really distinguish between the sensor endpoint and the IoT gateway and the black hole networks. And it is also responsible for network level security, switching and routing, and it is also responsible for translation of data between the protocols. Coming to layer 3, that is edge computing. Here edge computing performs on-fly data analytics. So this layer is focusing on data reduction and converting network data flows into information that is ready for storage and processing at higher layers. Here information processing is initiated as early and as close to the edge of the network as possible. For example, sensors deployed in a particular location may sense roughly some values. Instead of sending all the similar data to the cloud, sensed values can be aggregated, like taking average or summing up or some operation we are performing on that sensed values, and then they can be sent to the cloud for storage. When we are performing aggregation before sending the data to the cloud, it reduces the data volume and redundancies of data at the cloud. So this allows the data to be reformatted or decoded, and some additional processing is also done earlier. So thus a critical function is assessing the data to see if predefined thresholds are crossed and any action or alerts need to be sent. For example, if you take petroleum pipelines at remote areas, they need immediate action when temperature or leak sensors identify a deviation in the flow, or if they find any deviation in the normal temperature. So if you are considering cloud, if these sensors have to send the data to the cloud, then taking some necessary action, it takes long time. So whenever we want immediate action in real time, if we want the delay to be very less, then you can go with the edge computing. So here what it is doing is it is filtering the data, and it is reducing the traffic at higher level processing, at higher level processing. So it is making the data ready to process at the higher layers, that is edge computing. Coming to layer 4, that is data accumulation, means it is making the data to get ready for the storage. So networking systems are built to reliably move the data. The data in motion is converted to data at rest here. It also converts the event-based data to the query-based data. Here what is event-based data means, whenever we are having some sensors deployed in layer 1, they are gathering the data. So whenever some event is occurring, for example, if you are having some fire detection sensors, whenever a fire is detected, that is some event is occurring. So that data we are storing at the cloud. So when that data is stored at the cloud, it can be performed, historical analysis can be performed. If you want to perform on the fly analytics, we are doing it in layer 3. So here what layer 4 is doing is it is converting that event based data to the query based data. In future, if we want to predict anything, then you can use this historical data, you can impose some queries, you can get some responsibilities, then you can deal with that kind of data. So here layer 4 will determine to process the data, where to store, whether it on a disk, in a non-volatile state, or accumulated in memory for short-term use. Similarly, it will also determine whether persistency requires a file system, or it requires a big data system, or a relational database. Similarly, organization of data appropriately for the required storage system is also done at this layer. Here the data might be combined, recomputed or aggregated with previously stored data, some of which may have coming from the non-IoT sources also. Here this layer is differentiating between real-time networking world and the non-real-time application world by storing the data. So here it is converting the data in motion to the data at rest to perform some predictions or for better processing by the higher layers, and it is converting format from network packets to the database relational tables, and it achieves translation from event based to query based computing. Dramatically, it is reducing data through filtering and selective storage. So if you observe here, it is converting event based to query based. That is done at the data accumulation layer at layer 4. Coming to layer 5, that is abstraction layer, which is responsible for aggregation and access. So don't get the confusion between aggregation at layer 3 and aggregation at layer 5. So aggregation at layer 3 is reducing the amount of data that is to be sent to the cloud. On the fly analytics we are performing at layer 3. But here the data is at rest. On this we are performing some aggregation. This is historical analysis, you can say. That is at layer 5. So here layer 5 is abstracting the data in the data interface for applications. So here what it is doing is the data abstraction functions of level 5 are focused on rendering data and its storage in ways that enable developing simpler performance enhanced applications. It is responsible to handle and in-store processing of data from heterogeneous devices. Heterogeneous means multiple devices are sending data in different formats, so it is able to store them and handle them properly, and they should be put at one place. So here moving data into database is consuming too much processing power, so that retrieving it should be separated from the data generation process like OLTP, that is online transaction processing, like databases and data warehouses, to handle the data efficiently. And similarly, storage for event data may be relational database management with faster query times, and data abstraction must process many different things that include reconciling multiple data formats from different sources. At the same time, this layer should ensure consistent semantics of data across the sources. Here it should consolidate data and it should provide access to multiple data stores through data virtualization. It is also responsible for providing normalizing and denormalizing, and indexing of data should be there. When there is indexing of data, access can be fast. Similarly, the data should be protected here because all the data we are storing at one place, so we need some strong mechanisms like authentication and authorization to secure our data. Coming to layer 6, that is application layer. So all the below layers we are dealing with data. Now we are coming to the application layer where information interpretation is occurring. Means we are able to perform some analytics on the data by using some applications. So these applications will vary depending upon the device data and depending upon the business needs. The applications will vary. For example, if you take urban company ad in your television nowadays, it is also using IoTWF app to handle the customer needs. Means they are checking the temperature and they are checking whether the person is safe or not by using IoTWF app. Similarly, IoTWF app is also being used by the government officials to know the effect of COVID-19, and similarly which regions are coming to the red zone, which are coming to the orange zone or green zone. The predictions are being done by using COVID-19. Now COVID-19 by using Arogya Setu app. Means the Arogya Setu app is used by different applications for different purposes depending upon the need. So applications will vary based on the nature of the data and the business needs. Best example is the Arogya Setu app. Government officials will use it for the different purposes. The health department will use it in different purposes, and some private applications will use it in for different applications. The normal people, we the citizens of India, will use it in different ways. So all we are the stakeholders which are using that application in different ways. So for example, some applications are focusing or monitoring on device data. Some will focus on controlling the devices. Some will combine device and non-device data. So depending upon the application's needs, we are varying it. So here, this layer will deal with monitoring and controlling applications. Applications represent many different application models, programming patterns, and software stacks, leading to discussions of operating systems, mobility, application servers, hypervisors, multi-threading, multi-tenancy, and so on. Here the examples of the applications are some mobile applications that will handle simple interactions and business intelligent reports to generate and to perform analytic applications for business decisions. As I told you, the example of Arogya Setu app, and systems management and control center applications. Coming to layer 7, that is collaboration and process. It involves people and business processes. For a business, involving a single person is not enough. We have to involve more number of people, and you have to use the latest technology to improvise the business. So here layer 7 is the collaboration and process, that is the applications will execute business logic to empower people. So people use applications and associated data for their specific needs. Often multiple people use the same application for different purposes, as we have discussed before. And here applications at layer 6 will give the business people the right data at the right time, so that they can take the right decisions, they can do right things. So people must be able to communicate and collaborate, sometimes using the traditional internet or to make the IoT useful. So communication and collaboration often requires multiple steps, and it usually goes beyond multiple applications, not at all a single application. So at the same time, not only all these 7 layers, we also need some security which should be provided at each and every layer in the IoT World Forum standardized architecture. And this secure movement and communication of data between each level, that is from northbound to southbound or southbound to northbound, is very essential. So you should not forget some things like IoT is the baseline for standardized IoT. IoT World Forum has developed baseline to standardize the IoT architecture. Here the data is transmitting from the northbound to the center, that is generation is done from the operational technology devices, those are the devices in the Internet of Things, to the center, the storage at the cloud. And every layer should be tied with security, and it is offering decomposition of IoT problem. Decomposition of IoT problem is, for example, if you take any smart agriculture, having one sensors and predicting the data of only one particular sensor is not enough for effective smart agriculture application. We need to deploy some moisture sensors, temperature sensors, we need to fix some cameras, we need some humidity sensors. So we have to we are having a group of things which should monitor that agricultural land. So what we are having one problem, but we have to decompose it in several layers. Then you have to perform some edge computing rather than performing an historical analytics at the cloud. On the fly analytics we are performing. So the main problem, we are decomposing it and we are handling it in different layers in this architecture. Similarly, the network that connects them and the applications that will manage the endpoints. Similarly, the things to remember are to address the functionalities and concerns beforehand. Beforehand means after the occurrence, even if you take any necessary action, that may not be appropriate. So you have to address the concerns beforehand, before occurrence. So this is about the IoT World Forum architecture. Thank you.